Hi, and welcome to this video. I will explain the search in rotated sorted array. I have some examples on the top here, but don't worry about this now. I'll explain them as I go through. So the question gives you an integer array, and it asks you to find the index of the target. So in this case, the target is 0, and the index of 0 in this list is 4. So 0, 1, 2, 3, 4. In this case, the target is 3 and it doesn't exist, therefore it returns -1. But let's even turn it down a notch and start with a simple example with a perfectly sorted array. So when this array is perfectly sorted and you're trying to find the value for, what would you do? Well, what you would do is create two pointers and call them left, give it 0, and right, which will be the length of the array -1. Okay, so what you essentially done here is, let me clean this a bit, is you have had an arrow point at 1 and you have an arrow pointing at 6. Okay, and while left and right do not overlap, while they're not overlapping, because once they overlap, then they're basically repeating all their functions again. So while they're not overlapping, give me the index of the value in the middle. And that's basically left plus right divided by 2. So when I do this, I'm getting a new value, which is called mid. And in our case, mid will give me 2. So that will be 5 over 2 will give me 2. Not 2.5, just 2 because of this here. Okay, so now that I got the value of the mid, I can do a simple check and say if nums mid equals the target, then return mid. So what I'm basically saying is substitute 2 or get me the value of the index 2. So in this case, 0, 1, 2, that will be 3. Okay, get me, and does that equal to the target? I'm not sure we set a target. Okay, well, let's say the target's 5. Let's say for sake of this example, it's 5. So then you're checking, hey, is this 3 equal to the target? No, it's not. So nothing to do here. Okay, then we move on. So what do you want to do now if it's not here? Well, you know it's located on the right-hand side, so it's a waste of time to look at the left-hand side. So what you can do if you want to search on the right-hand side is you want to check and say, hey, is the nums mid? You want to check here. Bigger than the target. So is this nums bigger than the target? Or let me just write the mid here too, so then it's clear. So the question I'm asking here is this target, which is number 5 here, and if I get the nums mid, in my case it was 2, 0, 1, 2, so it was the value 3, and the biggest value here, so I guess then this can be right. So in this case it will be 6. So I'm asking, is this number target lying between mid and the biggest number? In our case, yes, it's there. Well, if it's lying somewhere here, then move the low or move the left, sorry, to here, to an index after the mid index. So then you can search this part here. And the way you do that is by simply doing left equal mid plus 1. Because there is no point of searching at this point anymore. So we just skip to mid plus 1. But let's say our target wasn't 5 and our target was actually 2. So if our target was 2, then move the high point to where it was lower than the mid part. So then that will look like else left equal mid minus 1. Right minus 1 in this case. Okay, so I'm moving this right pointer here. So let me just make it look cleaner. 1, 2, 3, 4, 5, 6. So if our target was 5, then I wanna, and this was my mid, I wanna move my mid pointer right here. Well, while if my target was 2, then I wanna move my right pointer to here. So that's why we have it down here. And let's see if this works. So I'm just gonna open the run test case, and I'll open the test case here, and I'm gonna say this is my test case and I want to find 2. Run code, and I see there is a mistake right here. I should have put it this way. Let's see if this fixes it. And here we see it does work. So I just changed the sign here because I have to check that the mid is less than the target, not less than or equal to the target, because then it's the right index that has to control the moving. So for our non-rotated 1, 2, 3, 4, 2 works nicely. Let's try to see if it works on the other side, which is 5. So I'm going to change this to 5 and click run and then accept it. So it works nicely. Now let me change it from non-rotated to left rotated. So let me take the example of left rotated and see if my code works. So in this case, I want you to find me 1 and I run code and I get the wrong answer. Now, why is that? And that's because this logic right here is no longer sufficient when you are left rotating, because here you're comparing 4 to 6. But in this case, when it's left rotated, you're comparing 6 to 2, which doesn't make sense, because if the number was 3, 3 will be located right here, but your logic is comparing 6 to 2. So you need to include a condition that actually checks if it is left rotated or it's right rotated to know that you're looking in the right side. So how do you do that? Well, you simply add a condition on the top here by saying if the number in the middle is greater than or equal to nums left. So essentially, what I'm checking here is if the number in the middle is bigger than the number to the left. So the number in the middle is bigger than the number to the left. Of course, it won't work here. So I want you to check if this number here is bigger than that, then it would make sense to check if the target is in between. So let's try this here. And the question said it should return -1 if it doesn't exist. But actually, there's no point of checking this because I need to write the else condition. What if numsmin is not there? So I can just write my else condition and then else if nums left is between the target and the mid, then I'm going to do mid -1 else mid +1. Let's have a look. And it works. So we added a condition right here. This is what we added, this condition, and it's else to check, to ensure that we are looking at the right side of the equation. So let's quickly check that the right rotated is also working. So can you find me 7, run code, and it works fine. And can you find me 4, which is on the right side, and it works fine. Okay, I'm gonna go through this again. So in the first instance, we created 2 arrows, left and right, and these go here and here. And I calculated the mid value, and on every rotation, I check if this mid value is the target number. If this mid value is not the target number, then I want to know if my array is left rotated, right rotated, or not rotated. And I need to know that in order to know on which side to look at. Should I be looking at the right side or should I be looking at the left side? So let's take the right rotated, for example. If 2 is bigger than 6, or if 2 is smaller than 5. So if my target was number 4, I need to first check, hey, is 2 bigger than 6? If 2 is bigger than 6, then there's no point to look at this side of the equation. So, and I have it highlighted here. If the mid here, yeah, is smaller than or equal to the left, which is not our case here, then go check if the target is located on the other side. And that's the whole point, really. We need to know which side is the target number located in. So now we know that the mid here is smaller than 6. Then we will enter this condition right here. And we will check. So in my case here, it would be 6, and the target would be 7, and then the mid would be 2. And yes, that's true. Then the right arrow will shift from 5 to number 1. And then in the next iteration, it will be the same thing. It's going to enter here again, and the target is between this number until it finds number 7. If not, if that's not the case, then we can simply shift the left to right here, and then it can check these values. If you have any questions, please let me know. Thank you for watching.